Imagine a car going 20 meters in this direction and then going back 10 meters in this direction. What is the car's speed and what is the car's velocity? Now I'm missing something. I didn't tell you time. Let's say it takes 5 seconds to go this way, and let's say it takes 3 seconds to go that way. So let's solve for speed and velocity. Give you guys a couple of minutes to see if you can figure it out, and then I'll go over it. So its speed is distance over time. So that means that how much distance did that car travel in that given amount of time? It went 20 and then 10. So its total distance is 30 meters, and it did it in 8 seconds. Now, if you want to leave it like that, you're more than welcome to do it like that. I don't care if you go any further than that. A fraction is a great number, and I love fractions. Okay? So that's the object's speed. Now, what about its velocity? I'll give you guys a second if you haven't written this down, and I will put it... Okay, looks like everyone's done. Velocity. Unlike speed, velocity is displacement over time. So it goes 20 this way and then 10 that way. That's 20 this way and then 10 backwards in 8 seconds. So its velocity is 10 over 8, and it's positive, which means that it is moving in a net direction that way. Find a place. Cool? Does that make sense? Let's try another one. Let's deal with the exact same numbers, but a slightly different orientation. It goes 10 meters this way and 20 meters this way. And it does the 10 meters in 5 seconds and the 20 meters in 3 seconds. What's its speed? And what's its velocity? Cool? So speed is distance divided by time. It goes a total of 30 meters and does it in 8 seconds. Now in this case it goes 10 positive and 20 negative. So that's going to be 10 minus 20 over 8 seconds, which in this case is going to give me negative 10 meters in 8 seconds, which means its net motion is in this direction. Cool? Does that make sense? So that's how I'm keeping track of the direction in which that object's moving, with that negative and positive sign. Positive means net motion is in this direction. Negative means net motion is in this direction. Cool? So far so good? All right, now this next term is probably the most complicated. This is the biggest misconception in mechanics. Acceleration. Now, acceleration is a vector, which means that it can be both positive or negative. There is a scalar equivalent to acceleration. Does anybody know what the scalar equivalent to acceleration is? No. Turns out it's unfortunately, in everyday vocabulary, we've been using the word acceleration in the same way that we would be using it as a vector. Now, not only do we refer to as an object accelerating as a positive change in its motion, we also tend to use words like braking and deceleration. Okay? All of those are in this category as a scalar. And we typically think of braking as a negative and a deceleration as a negative. But for this class, we will not be using the word acceleration in any other way than as a vector. So braking and deceleration and acceleration, when you hear those terms, we're referring to the vector components, not necessarily the scalar. And we will not be looking at these other terms. We may be using them, but they're not referring to anything other than our vector. Cool? So what does acceleration mean? Changing speed? So this one we will not use. This one is the term we will be using for acceleration. The change in velocity per unit of time. So when we're referring to velocity, what was the units for velocity? Meters per second? In the units for time? Seconds. So typically, acceleration is referred to as a meter per second, or a meter per second squared. Either one of those is referring to the exact same thing. I will try my best to use the meter per second as acceleration, because I think it's a little more intuitive. This is how much it changes, and this is the amount of time it takes to do that change. Cool? That is acceleration. Now, an example of a simple acceleration problem. The car is going 20 meters per second, and then 10 seconds later, it's going 50 meters per second. What is the acceleration? I'm working. So its velocity changes. It starts up at 20 and ends up at 50. So its change is actually v final minus v initial, which is 50 meters per second, minus 20 meters per second. How much it's changing by, which is 30 meters per second. And it's doing that in 10 seconds. So its acceleration in this case is 3 meters per second per second. Cool? Now if I were to do the exact same thing, it goes from 50 meters to 20 meters. Instead, my velocity is going to change from 20 meters to 50. So that makes my change negative 30, which means that my acceleration is negative 3 meters per second per second. Now normally we would say this object is braking, it's slowing down, but we could use an example that would prove that that's not always the case. Cool? Imagine instead, erase these, that it's going negative 20 meters per second, which just means it's going that way at 20 meters per second, and then 10 seconds later it's going 50 meters per second negative, that way. In 10 seconds, it changes to negative 50 meters per second minus a negative 20 meters per second, which gives me 30 negative, which then gives me the exact same result. This object is speeding up in this direction. It's not slowing down. So even though it's a negative value, the object is going faster and faster and faster.
But what is the equation would be written as 20 minus the difference, the negative?
Yeah, you can express it this way.
Oh.
Cool? Does that make sense? So if acceleration is the change in velocity per unit of time, when you're in your car, there are 3 things that affect your acceleration. Take a few minutes to figure out what those 3 things are. 3 objects in your car affect the acceleration. Take about 3 minutes, 5 minutes to figure that out.